Good morning, everyone. I'm gonna continue working on the minicast to see transpiling. Let's see, what do we have right now? Just see. We are trying to do this generic example over here, right? Where hello, Nigel. Where we are trying to imagine what we're going to compile the generic code into, where we actually need the any type working. Didn't see that would be the void star, but there is other things that are not here yet, specifically the lists. Yeah, I want somehow the lists to be present here. Um, Wait, hold on. I was just like having an idea. If the minicast is the simpler language, why don't we actually allow the generics here now? Is that good? Or is that not good? You know? Why don't we actually allow the generics in minicast? But it's not going to be generics. We can do the templates in minicast instead of generics. Right? Templates are a lot simpler, right? You know, like if I was to actually specify what is the list, so I specify everything else already, right? I could say that list is the struct. You know, that would make it a thing. But we don't like do type checking here. The only thing that we do and we only can do the top level ones, so it's going to be much simpler than what we have in actual cast. Okay. And this way I can like, and maybe like I compile my codes to this, and then the minicast could do the monomorphization automatically then, you know, if most of the things can be done like that. You know what I mean? So this would be like length, size t. What will list look like in C then? Yeah, that's a good question. What does list look like in C? Well, we want the length. We want like the data, right? Which would be a pointer to t. Which means, yeah, and then we can do like pointers like this and stuff, right? Pointer T. Wait, maybe pointer to T is the... Well, we want maybe like we just do reference to T basically, because that's the pointer. I mean, we can just do this. We just have this operator, the indexing operator. DB macro def expanded on the type T, or will all the use FT? The structure will replace with void star. No, I think like no, it's going to be the like the macro. I mean, it's not the macro. It's like the templates, right? Like in C++, basically, is what I'm thinking of here. So we don't do any type checking until we expand it, until we use it. Right? Like I definitely don't want the mechanic where we like type check it before the expansion, but type checking it after expansion, that is very simple. Right? And I can do that. And this also is the runtime. List index. I don't need this operator then either. You can just say list index. But we have to specify the explicitly the generic arguments too. Right? So have we are indexing into the list, which is the members. And this is the list of member infos. Well, I mean, maybe like, no. I don't know if we wanted to infer this. Technically, like, it's not impossible to infer this either, I suppose. But let's just do it explicitly here. Because if I don't do this, then I would have to like it's more like things that have to be built in, right? Like the lists. And this way the lists don't have to be built in at all, actually. Right? I can get rid of the lists. In the minicast, the less features we have, the better, right? And we, instead of multiple built-ins like this, we have a single one, which is the generics, the templates. Right. So, and then whenever we parse like a type, or whenever we parse an expression, or whatever, and when we see that it's a generic, we need to first expand it. And we would just replace this with like a list, some concrete type, basically. right? And maybe like I don't know about like if we still transpile the cast to minicast so that it will like be transpiled into these templates, then like the monomorphization can happen in the minicast, right? But not everything is can be done this way, I think. I'm not sure. I mean, most of the things that I use though can. And then maybe like all of the code that we have is already going to be able to run. There's probably some more features that are not implemented though. Alright, I was originally planning to not add the generics here, but we changed the plan. It's okay. We changed the plan. We are adding generics, templates. Templates, not generics. So we have the mini syntax. I don't think we have the indexing operator then. The reason we were having the indexing operator is because the lists were built in. So instead we say instantiate, which is going to be template dot args, the arguments to the templates. And then we have the list, and we don't need the list anymore. Unwind token is another very similar thing, which we don't need anymore. And we would just instead have the templates. Which is like somewhere over here, I suppose. Syntax, generic, at like 2.2, I guess. And this is going to be opening bracket, args, closing bracket, spice, definition. All right, so here's our runtime. We cannot parse this anymore. Wait, we cannot parse it. Why can I not parse it? Unexpected token, opening bracket, instantiate. Oh, because, yeah, we don't need a dot here anymore. Right, we just do this. There we go. We just have the unexpected top level item, which is the generic, right? Which is the template. Let's call it template, not generic. Okay, so the mini compiler, we will have top level item. Let's see, index. We're going to get rid of the indexing. List. We're going to get rid of the list. In this intermediate representation, we have the lists, and we will not have the lists or unwind tokens anymore. Wait, but expression shape, which is a list. No, we don't have to do it. No, we don't have to. We just need to allocate and like do it one by one. It's okay. A little bit too verbose, maybe, but I don't need this to be an expression even. I feel like let's simplify the language. Right, it's just like over here, for example, I'm trying to generate the member information about this stuff, and that is going to be not that simple anymore. Um, maybe it's okay. Let's not touch this yet. Kind array. Yeah. Let's go to the top level stuff again. Top level item, we have name, have value. We have type descriptions here. Constants cannot be generic, but these things can. Right. Oh wait, but how do we do this in the presence of? Yeah, we need to like understand that it's a generic type versus a generic function, though, before we like expand it, or I no, or yeah, or do we expand it? Like when do we like what happens when we expand it? That's the question, right? Because right now the way we work is that we figure out the names of all the types first, so that we can, when we like actually do the things, we can know if they are there. Why am I doing this? All right, so I'm not transparent to see right now, right? I can change the title maybe. Templates to minicast. Let's do that. So yeah, we just have the type names. I guess we would automatically do this whenever we need to instantiate, right? So we have this is the state of the minicast compiler, right? We would have the generics. So generics, we don't even store them as top level items, which we would need to process, I think. Right? Maybe. We will just generally have the generic. No, we have templates, which is going to be a map from string to a template, right? Okay. So what's the template? What is the template? So we will need to have the instantiations, right? Which is going to be a map from template args, right? A map from template args to the instantiation. Instantiation is just having a name, basically, right? So like generic type, we know the name of this type now. Generic function, know the name of the instantiated function. Template args is a thing which has the arguments. So what do we want to support as the generic arguments, though, is a question also, right? Do we only want the types there? Right. Probably, right? We probably only want the types there. I would think. I think only supporting the types there is totally fine, right? Just a list of types. And now we also have the definition, which is just going to be the AST, right? And we also know the arguments to the template, and this is just going to be a list of names. So we want only the simple names there, argument names. Right? Yes. Which means that if I have the top level item, which is a template, right? Then we need to so we don't add this to the top level items, actually. We add it as a template immediately, right? Right, we say context, no, we say state templates, add name template. So we create a new template, which has instantiations, which is a new ord map. Although we want a specific ord map because we need to specify the comparator for this. Because we don't override the comparison operators yet. So let me see. We have the ord map. Yeah, we'll have new with compare, and this should be the compare function, right? New with compare, and this would be compare template args. You know, that's the instantiations. Then we have the argument names, and we have the definition. A definition is just going to be well, let's see. We need to do this. Let args and definition is the root. It's the helpers expect two children. We have the children, which is args and definition, right? The definition is already the AST here. But the arg names, let arg names is a new array list, and we go for arg and AST iterate list of the args. Binary rule name is comma, and trailing arg name is some trailing comma. We say argument is arg ast helpers expect identifier. So like every argument must be identifier. This is the name. Arg names pushback argument. Right. I think this is all in terms of creating the template definition. I just need to specify how to compare the template arguments, right? So compare template args. It's just a function that takes two t's and returns the ordering, right? Right. Over here we need to compare the arguments, right? Where we just go. The only thing that we need to compare here is like for the equality, so that we can store this in the map. So we can first compare the list of them, right? So length of A is a args array list length. Length of B is that. If length of A is not equal to length of B, then we're going to All right, so we just compare their length must be equal, and then if they are equal, then we need to compare them element by element. So we will need to be able to compare the types too. Let's type A is A args at I, type B, right? And then we compare type ordering is compare type. We need to compare type type A and type B. If type ord is equal, then we don't do anything. I feel like I need the is not. Return type ord, but that's okay. Okay, so we need to like also be able to compare the types. Compare types. A type, B type. All right, so we're going to match on A and B, right? All right, let's see here. Boom, 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 boom. Let's see here. Something like this is what I want, right? So if they are both equal, like over here, then I return equal. But then we basically also check for every variant, right? Like any and then anything else. In this case, it is going to be less, right? Right. Then unit is equal. Unit and anything else is less. Bool is equal. Bool, anything else is less. We will want eventually to like generate this and derive the comparisons, but I think it is not working very well currently. Let's not allow the functions yet in the generic arguments. I'm too lazy to do this right now. Oh, wait, hold on. My language server crashed. There's no way. Why is that? Resource temporarily unavailable? Wait, what? I just cannot write? Because the resource temporarily unavailable? Is that because I'm writing too many logs? Because I'm printing... Yeah, I'm printing a little bit too much, I think. Well, I can restart language server, right? Let's do over here panic to do compare function types. Okay. Native A and native B. We'll do std default compare string IB. Same goes as over here. Named A and named B. We compare the names then. Right, if we have named underscore less, if you have referenced A and B, we return compare type AB. And if you have a reference at anything, it's going to be less. Do I need to also do the greater one when it's on the other side though? I do. Yeah, I do, right? Let's find all of these. We return less. And then we like copy this stuff. We return greater. But then we say underscore and this, you know, on the other side. And that's how we compare. Okay, I think this should work in terms of comparing the types. Compare template arguments. That works. Okay, let's see. This is also not going to compile yet. Just build. I'm not expanding the things yet, but let's first fix the other compilation errors. I guess I have to. Let's see. Ordering is not unit. Right. Yeah, because over here there is no semicolon. It looks like we don't need to return either, so we just do that. Okay. So when I initialize the state, I need to have the templates, and this is going to be ord map new. Right. Yeah, this over here list is not something that we need to have, right? List. Because we get rid of it. Type info. Yes, and we don't have this list anymore. Here. Let me just comment this out. So these two things is the interesting one. Well, this is when we do the type info specifically. Let's maybe work on the other things first and then fix the type info. Like, how do I create this expression is the question, right? But this one is specific for JavaScript. So maybe like, and then we will have like, yeah, the specific ones, maybe. I might regret adding the templates here, but I don't know. Okay, so now in the JavaScript there is no lists, right? There is no lists. There's no lists. Get rid of it. And in the C backend, there's also no list. Unwind token. No unwind tokens, no lists. Okay, so this works. Let's see what's going to happen. What's going to happen? Let's do the JavaScript genetics. Right, so it says unexpected token here now, right? Yeah. Yes. So now when we have the generic function, we want this is the members. Members is going to be the list, right? But this is no longer built in, and we need to say like list index. This list we index it at 0. That's okay. Expected at type got list member info, right? So this is where this happens. So we need to instantiate this thing now, right? Whenever we are parsing types or expressions. Let's see, what do we have? The parse type. Right? I say that if rule name is equal to instantiate, right? Yeah. So we need to instantiate this thing, right? Template and args is, how about we do like instantiate root. I feel like instantiate should be, so this would be the st group, I guess, and this should return the instantiated. I feel like we should be able to instantiate to either a type or a function, right? Like those are the only two things, right? We have the type, name, or we have the function name, right? Yes. And then over here, we're going to match instantiate root with, and if this is the type name, then we return the named type name, right? But if it's a function name, then we want to say that we expected a function. We are going to do the diagnostic here, like this. I'm going to do the error, right? We don't care about the name. I feel like we just expected type got function. Does the language also have generic values? I know Haskell does. Yeah, but with the minicast, it should be very simple. I feel like it's going to be easier if I add the templates here, instead of like hard coding more things like lists, unwind tokens, and do the thing. Yeah. I feel like it's easier. And these are templates; they're not generics. That's a very big distinction from what we have in Kast versus what we have in minicast. It's basically a macro. Right? I mean, if you were writing C, you would literally do a macro, but you would yeah, that's what you would do. Wait a second. Oh, wait a second. Is that what I do? Hold on. Maybe we don't instantiate here. Wait a second. I'm having this idea where we would also instantiate explicitly. Maybe this is better? What do you think? So we will not be able to say over here list of member infos. I want to instead every type that is generic, if I wanted, we would literally do it as a macro. Literally. Not as generic and not as templates. So I would say list of member infos, you know? I have the list somewhere, right? And I would have to instantiate this type. List member info is basically, yeah, exactly, closer to how we would do it in C, right? Minicast is supposed to be the simple language, so if I don't need to do this complex logic to figure out if something has been instantiated already or not, right? We literally just do this list of member infos. I like this. I think that simplifies it a lot. I think. I mean, it's not that difficult to instantiate on demand, but yeah. because then like I can potentially instantiate it when I'm like parsing a function, and like like yeah, it's just like a little different, right now I'm like processing all the types first, and then I'm processing all of the functions second. It doesn't have to be in this order, but yeah, I don't know. Let me think. How much more difficult is it to do it on demand? Well, doing it on demand also means that I need to do these like comparisons. Has this already been instantiated? Has this already been instantiated, right? Which potentially can hurt performance, maybe, if I like need to do these comparisons all the time. This way I don't need to, right? Hmm. Maybe I do that. Hmm. Um, could also remove any forward stuff from MKS. I don't think I have any forward stuff. What's there to remove? Super smooth top to bottom compilation. No, we do like multiple passes because we need to like first figure out all the functions. You mean no? If I add the forward stuff, then I can do smooth top to bottom, like C, where you have the function declaration before the function definition. If you want to like use the functions that have not been defined yet. Let's do this. I do like that. Maybe. It means that I don't have the instantiate. It means that when I'm parsing the type, it should not figure out the instantiations. Nope. Instantiated is not a thing that happens. Instantiations is not what we need. We just have the template, which just has argument names. And I don't even and I don't even care about what the argument name is, because we just pass them as ASTs. And that is it. C forward declarations are one way of dealing with that. That's probably part of why it compiles so fast. I mean, yeah, maybe. I don't think like it's that big of an issue. Like back in the day, it made more sense because like storing the entire program in memory was bad, right? But these days I feel like the overhead is negligible of doing multiple passes here. Yeah, so we have like just the template, which just has argument names and definition, and that's it. That's literally it. And I don't need to compare. I don't need this. I don't have the template args. I just have the templates. And templates just like this. Yeah. There you go. There you go. So the only place where I can use the templates is in the top level definition. Okay? And this is when I expand it too. Which means that when I have the top level item, I kind of also need to know my template arguments here. Like if this top level item was generated by a macro definition, Do I ever want to? No, probably not. Jai doesn't have very long to parse either. Well, parsing is different from compiling, right? Parsing doesn't need to know the forward definitions. Yeah, I don't think it helps really like much. I feel like it's more that when C was first appearing, they were trying to save on the RAM, right? Because in order to do out of order, you need to store more things in memory, basically. I think. Right? And when you do the C, you basically can like generate the code as you parse. Or something like that. Anyway. So I think the top level item should have the generic, should have like template arguments, right? Which is going to be also a map from a string into the AST, basically. That's what we want, I think. Well, I mean, do I want that actually? Maybe I don't. Maybe I want to just literally replace the ASTs in place. Maybe I actually want to replace ASTs in place there. Do I? Hmm. So we don't do the instantiation, we just have argument names, definition, we add the template, right? But then if the thing that I'm defining is right, so if the rule that I'm using to define the top level item is the instantiate, so we only allow that in the top level, we say that template and args is root expect two children, template and args. So in this case, we need to make sure that we find the template. Template in this case must be a simple identifier, right? So template name is template expect identifier, right? Now we need to find the template. So we say state templates template is state templates get template name unwrap else could not find template. named template name, right? Like this, and this would be on the template span, right? There you go. And now all of these arguments are just going to be my ASTs, right? We want to make sure that the amount of arguments is the same. So the question is, where do I do the substitution? Do I do it over here, and then like I have the AST with substituted things, or do we do it in some other place? Do we remember this and then do it later? Because like in order to report better errors, I might need to know both spans before and after it is expanded into the actual argument, right? What I want to return here. So we have the template definition, which needs to be substituted, right? We have template definition. This is the AST. And then we have the arguments. And we need to like, I need to add the top level item here again. Right? Yeah. What is set top level definition? Oh, this is me just checking that it doesn't exist yet. Set top level definition span. Right. Because it has already been defined. Yeah. For the name collisions, sure. Should the tree-seater grammar generator be a Kast CLI subcommand and live in its own repository? I think it should be a subcommand, so that you can generate the tree-seater grammar for anything, right? I mean, I don't know. Yeah. How would you do it in another repository? You would need to import Kast as a library, right? I guess you can technically do that, but I think it's okay. I mean, you can edit as a library and like import these certain things only. I think I'm okay with doing the tree sitter here directly though. Yeah. Yeah, just do that. You want to work on this? On the tree sitters? Okay. What's value? That is the value. Okay. Okay. That's source AST. This function is pretty long, is it? Yeah, it is. How about we do this? I want to do the type definition. Let's extract this into top level function. Type definition is that this would need this state, but state in this case would just be the context, right? Is that my context? Yeah. So should we set the top level definition? This is set top level definition span. I think that's a better name. Right, so we like first when we do the top level item, let's do that. Add top level item. Is a function which takes the AST group like this. So after we set the top level definition span, over here, so this is the constant, right? I will want to set the value, right? Okay, so this is not like add top level item, but like set top level item. I don't know. Is it a different top level? Item, because we need like to have basically already the value, then the name and the value basically, right? Name is the string, value is the AST. Set top level item, name string, value is AST. Right. This is where we would have all of this stuff basically. There's still state here. Context now. So when I add the source AST, we iterate over these things. If it's a const, we say add top level item. Root Well, then I suppose a total item. I mean, this over here could be done in line there if I wanted. A total item root. Otherwise, we expect const name, right? Yeah, there we go. Yeah. Okay. So now the instantiate, the reason for this is because I just want to call this function recursively, right? Because this name is now not this value, but like this new value, and we're just going to do it recursively. Right? We just say over here, set top level item, name, definition. But then we also need the, so yeah, we have like the value, which is AST, and then we have the generic arguments. So what do we do about those? The arguments, when do I substitute them? I mean, I can substitute them later, probably. Okay, to do that. I just need to now remember to do that every time I'm looking at every AST. Which is why it's probably better to do it here directly. Okay. Hold on, is there like a way for me to do this in the AST directly already? Like, because we need to like walk the AST and potentially substitute it. I do have the option to do that in the highlighting, but I need to do it in the AST walk-in itself, right? I think. I think I have a little bit of a cursed solution for it. Currently, when I'm doing this syntax highlighting, yeah, we have this thing called replace AST. Yeah. And that is used when I am doing the structural find and replace. We could do a better solution and then like reuse it here too. Although it's not that easy, I suppose. Like what we want is something like this. We want to say that definition is AST replace. You know, we want to replace in the definition. So template definition is the AST, right? And I want to replace there. And we want to replace there. So we want to give it the function which takes AST, right? And then says that if this is an identifier, right? So if AST shape is a token is a token with identifier is the identifier token. Let's just say token. Token. If let's just do the return here. If token shape is identifier name I will need to like look this thing up. So by default I just return the AST back, but if this is the argument that I want to replace, right? So over here we have the arguments. Let's say args. Let's say args. This is going to be an ORD map from string to AST, right? So I'm going to walk these arguments, and I do have the template, and we do need the same amount of arguments, right? Let's say index is 0, and then we do for argument in AST iterate list of the args. Binary rule name is comma. Trailing or leading is some trailing comma. Right? So we have this. We do I plus equal 1. And then argument name is the template args. It's called arg names. Right? So we want the arg names at index I, right? Let's args expected args length is the length of the template arguments, right? So over here I also say that if I is greater than or equal than expected args length, I want to do the error saying that too many arguments for the templates for the template. Right. In the end, I also want to say that if I is not equal to expected args length, then we're going to do the diagnostic saying that there's not enough arguments, right? Not enough arguments for the template. But now we have the name of the argument, and we say that map add arg name and arg, right? So here's the AST, this is the name. Need to do reference here probably, right? And then we have this map here. So we have the map of the arguments, we have this identifier, and then we say that if 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 args get name is some AST, right? Then I'm going to return AST like this. Argument AST. Right. And this is my definition. And now we need to just specify the IST replace. This can be like a more general purpose thing. Right? Which is going to be we want to replace AST, and we have the function, and the function is taking the AST and returning AST, and this returns AST, right? We just need to apply this function not only at the root but all of the children basically. How about we do this, and then we see. Well, I don't want to replace it in place, right? I want to construct a new one. In this case, I suppose. Walk. Replace AST. Can I have like this as maybe? Reset the context. We replace context, and we should like replace AST. There you go. So over here we just like call this function first. Are we really working on C? Well, right now I have like went back and I'm adding the templates, but yes, after they are done, but maybe I will not be working on the C actually. You want me to update the description? Do we even call these templates? It's kind of like a macros. Simple macros. Simple templates to minicast. HTML support in Kast. What the fuck am I seeing? You didn't see anything. Don't tell anyone. It's for the website. No, it's not the website. It's the bottom of the stream over there, where I describe what I'm doing currently, which is not always like, I'm trying to keep it like updated, but sometimes I forget. Especially because I didn't plan to work on the templates when I started this stream, but then I thought that I should. So now here I am working on the templates. I originally did not plan to add the templates to the minicast, but now, yeah. What do you mean boo spike? You don't like C? Or what? You wanted me to keep doing the JavaScript? Or what do you mean? Or are you booing the templates? What are you doing here? You don't like not working on C, but you made it. Yeah, I it's like basically here's the thing that I was trying to do, right? I need like lists. So like there's two options to do the lists. Either I add them as like the built-in feature in minicast, or we just allow the simple templates where in C the list would be like represented as the pointer plus the length, right? Like this. And then I don't need to like build this into the language. And there's like other things similar to lists that I would need to like hard code if I don't have like this way, you know. I don't want to, though, like I said, we don't want like the list T. Wait a second, how do we do this actually, now that I'm thinking about it? Hold on a second. How do I list an index? How do I make a generic? Hold on. Do we need the instantiations? Like I obviously like I can do the generic type this way if I do it like C with a macro system. Do I go back to instantiations? Oh no. Like how do I specify the function that lists the index? That gets the element of the list at a given index, right? Because how do I expand this is the question. Read chat. Receiver grammars are pretty much already your syntax statements. Yeah. Only notable disclosure is that the value in your rule can only be refined to a specific syntax rule. In TypeScript grammar. In receiver grammar, right. Well, we can refine it to be a specific like syntax rule set. I think this feature is not implemented in the self-hosted one though, right? But when we wanted to like embed the SQL in Kast, you can basically say that specific value can be like SQL basically. And for that you would need to like use that tree seeder feature, right? But yeah, like I said, yeah, it is basically the tree seeder, I guess. Maybe that's what I have re-implemented here, tree seeder from scratch, I don't know. List index. How should this work, right? Like if I, so the, I have removed the instantiations and thought it would be like simple macro system. How do you do this in C is the question. How do you do this in C? So you can like define list by like, if this is a macro in C, right? Then you say like list C and you say that like list of integers is the list of integer, right? So like that's how you like, you just invoke the macro, you create the definition, right? But how do you use this type now in a generic function? Like, is this also a macro, but a different macro, which expands to a name, not to the definition, right? But how do you expand to a name like this? Generics in C. Generic selection introduced in C11. What? What is that? To choose one of several expressions at compile time based on the controlling expression. Huh? Let's see. Bum, 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 bum. Bum, 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 bum. Is this the vector hashtag t? That's how you define the name, right? So like we would need this support to have a hashtag t. And this is what? It's concatenating the identifiers. Oh my god. Is it not easier than to do the actual instantiations and do the templates like in C++? Because the name mangling will be borked due to the star, the solution is to type def the pointer types or wrap them in a struct. You want to write code manually, but you just cannot justify spending time on it now that Claude is so fucking good. That means that you don't want to write code enough, I guess. I don't know. You have a full-time job and don't have the time to dedicate to solving problems deliberately and building a detailed understanding. Yeah, I think I have to do like C++ like templates here for this to work. Because, I mean, yeah, like I can define the types like this, but I cannot use them in a generic function. Unless I don't do generic function, I only do like generic type descriptions. But no. All right, so I just deleted some code that I need to bring back. Is that what it means? No. Oh. So it means that like over here I'm parsing the type, right? This should be expanded to a type name, and we automatically generate the names for it, and we don't like create this in explicit instantiation then after all, right? Well, I mean, I can have the explicit instantiate. Now that I think about it, we can combine both of these. We can have the explicit instantiation, which is how we generate the name, and now over here when we like want to get this, we will, because it was instantiated previously with a specific argument, we know that this is the name, right? Although this seems like an unnecessary step then. Um, and like, what is the argument here? Then it's not like the AST or something, right? We need to resolve the aliases and stuff for the arguments. It's not based on the ASTs anymore. All right. Well, at least I have realized this before. I have more stuff. I feel like this replace is not going to be needed then. After all, I just go with the original plan of the C++ like solution. We don't do like all of the things in C++, like the substitution failure is not an error and stuff like that. We just do the automatic instantiation. Which means that we need to figure out like the actual name, the monomorphized name of this thing. All of the arguments are going to be just types. Yeah, and this would mean that we need to we would also need to have to process the types and functions like. Yeah, I would need to like make sure that when I instantiate this, then that I fully process this type, so I know all of the type information about it. Maybe I should like think about this more before going on a little bit, at least. What if we like do some other simple stuff then instead? Well, but now I broke all the things that I had working previously because I removed the list types and stuff. Hmm. So we will have the instantiations here after all. The trick is to simply not give entropic money so they don't let you use the thing. Works great. Right. Wait, can you not use Claude for free? Or is free one not very good? It says free for everyone over here. Look at this. Free for everyone. Not the Claude code. Right. All right. Can I can I get back to like where I was having this code with comparing, because I have not committed anything. I was still in the process. Can I just get back so I don't try it again? It's not like that much, but I want what? The comparing of the templates. Code code is expensive but way smarter, rip. I see. Do you think it can implement the templates for me in Kast? Is it that smart? This over here is what I wanted. We don't care about how the code looks at all, then maybe. Alright. Compare template. Alright. Okay, so we have the template and we will have the instantiations. Right, which is going to be an ordered map from template args to the string, which is the name of the instantiation. Well, I mean, it should be instantiation. Yeah, how about this? We have instantiation, which is because it can be instantiated into a type or into a function. And this way we know what it is. Dun, 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 dun. Okay, so instantiate is something that we would do not here in the top level item after all. But somewhere else. Let's see, we will have the thing called instantiate. Instantiate. This should give me like the AST group, and this should return the instantiation, whether it exists already or not. So we have templates, we have arguments, we do figure out the argument. Yeah. Okay. No, we have the arguments. This is supposed to be the template args then, right? Where we will return the dot args is list, sure. We'll have the list. Arguments is the list of types. Right? So now I'm going to have every argument. Well, I mean, I don't need the argument name, technically, in this case. Wait, no, I do need. Oh, they are in order. Okay. Let's not do the arg name. We have the list, array list, push back. So the argument in this case is the AST, and I need to parse type, which is the argument, right? So the arguments must be types. Now that we have this, we can look up the argument in the current instantiation map, right? One second. We have the context template. We have the arguments. Now we need to figure out if we already have it, right? So context. No, it's not context. It's just template that we already have. We need to have the instantiations of this, and we need to say ord map. We have the we have get or init, like this one, I guess, is what we can do. Get or init. And this would be the function that actually does perform the instantiation. Do instantiate. Do instantiate is a function which it's not exactly like this, because we need to know, not like actually created. We need to, over here we're generating the name, and then if we are generating it like, yeah, it's hold on. We need to like say that do instantiate is true, if you know what I mean, right? So we need to mutate this, create the name there. Do instantiate is false. And over here I need to like generate the name, right? Because this is, yeah, we get our init by the args, right? And do instantiate means that instantiate, and then we will do something. And over here I just need to generate the name for it, right? I need to just generate the name for it. Well, I think it's relatively easy. We need to output the string. For arg in args iterate. It's args.args, right? I want to print type name as identifier, right? We have this thing. We can print the argument like this, and then we will say also write the underscore. And over here we are writing the template name, right? Yeah, there we go. Template name and every argument with an underscore, and that's our name of the argument, right? That's the name of the instantiated thing. Right? Wait, there's a, like... Mm. So the way I was doing it here, we were figuring out the type names, right? Before processing the types. What do I do here? Actually, it should be fine, I think, because like when we do it recursively at template stuff, I will just get the name already, right? Yeah, I just don't wait. But I don't know what the instantiation should be. Should this be a type or should this be something else, right? That is the unknown thing. I mean, we can know this thing though, right? Based on the definition of the template. All right, because this should not be just a string. It should be either a function or a type, right? So we will return the instantiation here, right? But so this is the name, right? Let name be this. Like the question is, when do I parse the definition, right? Like if I am right now inside of a function, and I'm like referring to another type, I need to do it immediately. I mean, can I like always do this immediately here? Can I always do this immediately here? Maybe I can. Maybe I can. So actually do instantiate is a function for all, which is doing these things. So when we do need to instantiate, we need to generate the name of the instantiation, right? And then we will look at the template definition. How am I doing this? Yeah. Top level item. It's kind of similar to the top level item, right? Should I... I'm not sure. Let's try this. Let's try this. I'm going to match template definition shape. Well, this one must be a rule anyway, right? Rule and root. Unsupported template definition. Now let's just say over here the template definition span like this for now. So if this is a rule, and we say that if rule name is the function, then we will return the function, right? We'll return the function name. Otherwise, we will return the type name, right? But we need to actually perform the instantiation, right? Which means what? Type def. We have this, right? We have the type define kind and root. Oh my god, why? I mean, we just have like enum struct and unions. Type alias. Generic type alias. Maybe should also be there. Like, how do I not copy paste here is the question. Don't you kind of like similar things like this? Okay. Maybe I will like, let's just make something work first and then figure out how to make it nicer. Right? So here's all the things that we need to do. We have type alias, enum, struct, union, maybe not opaque type, function, and that's it. So we don't add it to the top level items though. Right? We literally just say type def. Well, type def over here just adds it to the top level item. How do I like process the top level item? Process top level function. Let's see, right? So here's how we're compiling currently. We're going over the top level items. First of all, we figure out the names of the types, right? This is something that I guess like is not like really needed, because when we see the generic thing, we instantiate it and we get the name back. So that's like not needed, right? Then we pre-process the top level functions and do the context too. Top level functions pre-processing means that we need to like figure out the types of the functions, of all of the functions first, so we can like figure them out. And then if we have the types, then we need to like process these types, right? Okay, so there's like a process. Yeah, we need to process struct or union, process enum. There you go. Right. Can I over here instead say process type, where I say name, kind, and definition? How about this? Process type is a function. Name, kind, type, kind, and definition, which is AST, right? This type def function was also splitting these root into, like, there's supposed to be a record there. Type name, type name, type name, type name. Yeah, just say in this case that definition is that, right? And I need to process type, kind is alias. So this is having name, alias, definition, right? We need to process all of these here instead of type defining. this should be union, this should be struct, and this should be enum. But the definition here, what is the definition? Right? That's in the type def function. I mean, this just extracts the definition, right? So should this, let's have an extra function called extract type definition from the AST group, right? And this will give me the AST, right? There we go. Then I can use this and my instantiations here, right? So in these three cases, we just say that definition is extract type definition from the root here. And then we know the kind, the name, like these things. Okay. So then we process these types. If we have a function, we need to process the function. We need to, I guess, both pre-process top level function and process the function at the same time, right? Pre-processing is when we add the function type, so we can like figure out that, right? And then we also process top level function, which is parsing the function definition and adding it, right? Instantiate. So if there's a function which you pre-process top level function, so the definition in this case is just the template definition itself, right? So we need to pre-process. Top level function, which is name and definition, and then also process. Right? This is where the templated functions would not be able to recurse into each other, though. Because right, yeah, because it's like pre-process and then process it later, actually. To do wouldn't work with recursive related functions. Okay. I think I'm getting somewhere. Okay, now I just need to, like, when I parse the types and first of all I need to make it work with the types, right? And then I will need to work it with the expressions to for the generic functions. Let's see if it compiles though first. It does not. Context is not found. Templates, add templates, right? Because this does not have the instantiations, right? So we need to have instantiations, and this would be ord map new with compare. compare is going to be compare template args, right? So over here we return. What is this? Set top level item. Just have a return here. Name definition is not string AST. This one for some reason has named arguments and this one does not. It's okay. Let's not think about it too much. Template is not mutable. Or what is not mutable? Yeah, because template is this, right? We need to have mutable templates, and then we need to do ord map get mut, because we need to mutate template, the instantiations of it, right? Instantiation is not mutable instantiation. Where? Yeah, I need to say like, yeah, we're going to have to reference like that. I cannot find state in scope. It's going to be not state. It's going to be the context. Okay, seems like it's compiling, but it's not going to work yet. Because I still cannot parse the type which contains the generic. Right? Oh wait, cannot reach purpose of undefined top level item definition span. Top level item. Yeah, it's because when I'm adding this source AST, I'm adding top level item root. Right, I need to like set the context here with context being state. Wait, what? In this case, it's mutable state. Right. Yeah. Well, I mean, like the problem is that we need to mutate the state, right? But this takes an ownership of this thing value. which is wrong. This is going to actually work right now because we are doing the JavaScript stuff, but it will not work when we are out of JavaScript because it will copy the things instead. We're probably having the same issue in multiple places, but to do this copies state, this will copy state. Need context to be a reference. Yeah, maybe the context should just be references always. I'm just thinking if this should be like, yeah, I don't know. I'll think about it later. Okay, right now it will work with JavaScript. There's going to be so much debugging when we have the C working though. Nothing is going to work. Probably. Okay, so now we have the unexpected top level item over here, right? We don't do this. So we don't explicitly instantiate. Unless we do like the type, right? Because this is going to be an alias. Over here, this means that I am parsing this type. Right? I can. But then it says that we expected a type, but we got the list of member infos, right? Right. So now this means that when I am saying parse type, oh, okay, we need to figure out if this is the instantiation, right? So if rule name is instantiate, then let's see. So we have the instantiate thing. It just takes the group. Okay. Thank God the undefined behavior language lawyers are in chat. Are you talking about yourself? Ray March. I'm adding the templates to minicast now, which are going to be C++ like. I don't know why I'm doing it. I'm kind of regretting it, but at the same time, I think it's not that difficult. It's just I was assuming that I would not be adding these. So we have like these instantiations now. Your stream delay is long. Monomorphization. Yeah. Well, I mean, they are basically like macros. So in minicast, I will type check only after instantiations. So, right, which basically means that they're macros, right? They're C++ templates. They're not real. Yes, which is also giving me monomorphization automatically if I transpile to this stuff. I suppose. Although, like, I mean, the only reason I wanted to do that is because I wanted to not copy paste code basically in the implementation of the runtime of minicast over here. I think it's okay. Don't think about it. It's not Kast, it's minicast. It's different. So instantiate the root here, and then we are going to match this with, this is the type name. Then we're going to have a return named name basically, and this is my stuff. Yep. And if there is a function, then I need to add diagnostic here. Test. I think there is a button on Twitch in the settings of the stream, the low latency or something. Okay, I want to say over here that this instantiate, okay, wait, hold on, I broke my language server again? How did it crash? It doesn't even say why it crashed. It just crashed. Can try it after a stream was destroyed. And there is no like stack trace for some reason. Okay. Weird. So just say output right expected at type got function. Okay. So we're saying that this is a function. Maybe like with instantiations could like give you more information, so it could like make the error message. This is where the template is defined or something. I'm too lazy. I want something working. Let's see if this works. Okay, it says expected a type got list member info, which means that it did not work. Which means that it is not the instantiate. Wait, did I hold on. Did I make a typo here? No, it's called instantiate, right? Oh, wait. I did make a typo. My bad. Now we need to wait. Is it what your C++ work looks like very much? Like staring at the compilation? And then you have the errors, and then sometimes you have runtime errors instead? Nice. Does your C++ compiler sometimes run out of RAM, like my Kast compiler does? Now we need to wait even longer because we need to restart it. How much RAM am I using right now? I mean, I can give it like more RAM. I'm limiting it to 10 gigs right now. Yeah, the ICs at work, yes. Look at this RAM going up. 2.2 gigabytes, 2.3, 2.4, 2.5, 2.6. That's now 3 gigabytes. And it grows and it grows. Also, you will push after testing it on 2 machines, and the build will break on the third when your worker tries to review. Right. 4 gigabytes. 4.4. 4.4. It actually stops. Okay, it's compiled. Let's go again. All right. Now cannot find template named list. Oh wait, what? Wait, what? Oh, actually, I don't have a list. That's right, because this is the JavaScript backend, right? I wanted the and I only did it in the C backend. So in JavaScript, actually, the list, the list is a template T, and we don't even use the T here, right? This is just a native. This is just a type native, you know, array. Well, I mean, I don't think I support the interpolations here. Do I? Let's try. It's arrays of t's like this, I suppose. Is how we would write this type. But yeah, we expect a string token, and this is the interpolated string instead. Let's just call this any here. For now, it's okay. Oh no, I think we are having the infinite recursion right now. The instantiation leading to another instantiation, leading to another instantiation. Is that right? That's probably what's happening. It's also leaking memory. Hold on. 2 gigabytes, 2.1 gigabyte. No! No! Stop. Why would this be done like that? It's wait. I'm suspecting that the comparison is the one that is broken. I don't know why would this be broken though. Let's do instantiate over here, right? How about like we calculate the args, right? Let's dbg print 1, 2, 3 calculating template args calculated, and over here I want to do the you know, instantiating name. Let's do that. I want to see what's happening there. Right, I'm just processing the time. Yeah, it's because like I'm doing this but the list is not recursive, so like it's supposed to end. Actually, right? Wait, so I have instantiated list member info. Hold on. And then I use it again, right? And the second one is already instantiated. Is that right? Log. debug message instead of debug print. Log debug message. Log debug message. Log debug. It seems like it's not the instantiation. That is broken. Right? So we know over here that list member info is the type list member info, right? So we have generated this type when we were instantiating this. Same goes over here. Is it because this is an alias? For some reason, now it says list member info is not found because this can be just like that. This alias is unnecessary. And this list, this is where we construct a list. Okay, so now in order to construct a list, we don't want this actually, right? We want how about we do members? How about we do members? So what we want is we want to say members is allocate a list of member info with like 1, right? And then we want to say that list index members 0 is equal to member fields, right? And that's how we initialize it, right? And so we need the allocate list here, and index list also into the list of member infos, right? Like this. So we have, and now we wanted the expression, but we got the allocate list member info. Yeah, why is the type alias, which is recursive, like this? Oh, wait. Oh, because this is the alias to itself. Because, like, yeah. It's the alias to itself. And to make sure that, like, it doesn't happen. It will not recurse if it's like this. Because it's trying to resolve the type aliases. and it says that this is the alias to this type, but this type, like this name becomes this name basically, because of the way we're doing it. Yeah, that makes sense now. Okay, and to detect that probably and like do an error or something. Yeah, when I instantiate, like this name should not exist basically. Before, right? I probably have this, right? We have set top level definition span, right? We have the name and we have the span. There we go. Yeah, that's what we want. And this will give me the error. So when I instantiate, right over here, I do instantiate. So we have this, and we just set the top level definition span of this name to be the root span. No, it's not the root span. This is where we instantiate. Well, I mean, we can't like consider the instantiation span as like the definition span of the time of the thing, I suppose. So yeah, this actually works, I suppose. Sure. Okay, and then we want, when we parse expressions, do the same stuff, where parse expression impl, right? We want to say that if this is the instantiation, right? So I'm trying to parse the expression and it is the instantiation. This must not be a type, right? Expected an expression got type. But if this is a function and the name, then this is where we just return the reference to this function, right? Which is supposed to be, well, now we need to like figure out the function type here, right? Which is technically the identifier, right? Boom, boom. I mean, this is what we do. Yep. We return shape is place identifier name, and we find identifier type, which is going to be the root span, and the name is name. I think that's what we do. Let's see if it's going to work. It is not going to work. I already know it. Because we don't know what's the type T. Right? Because I'm not looking at my generic arguments. We also cannot find the allocate list itself, so let's see. We want in the JavaScript runtime list index. See runtime. Yeah, we want like list index, and we also want the allocate list t size. And it should return the list of t's, right? We want this, and we want this in JavaScript. So allocate list will just return. I think in JavaScript we can just do the empty list and we can index into it properly, right? Does this work like this? If I say that A is equal to, you know, like an empty list, and then we say A2 is equal to 5, then we have 2 empty items and then 5, right? And then, and then we can like initialize it like this, and it will still work. Yes. But if I do A minus 1, A minus 10 is equal to 500. Right, so minus 10 is like the string key then. Okay, got it. Nice. Okay, it just means that we don't really need to allocate anything here, right? We just say that it's a list. Then we do the list index. This is a reference to the thing. Right, so the references, we just represent them as the getters and setters, right? We say get is a function which returns list at index, right? And set is value into list at index is equal to value. So this is what we return. I think this should work. Yes, but then it says that T is not found, right? So over here, what is the type T? Now, because this is a generic argument, we need to do that, right? Because this is the generic definition. Yes. Okay. Compiler. Here's what we're going to do, right? Do we have a scope? Do we have scope here? Yeah, I think we need to have a scope. And we will have the parent scope. Can you make a PR at a common module containing all the files? Read at compile time? What does that mean? Thank you very much. LSP gets the syntax definition, compile time, and skips it. So what? Why do you want that to be in a single file, though? I do think though that we should I think when I'm developing this locally, like there should be like I think maybe an environment variable, which is if it's set, then we don't use the thing. It's going to be shared in lots of places and even in tree-sitter gen now. I think I have this, you know, I think I have mini. I have this syntax rule set path, for example, for the minicast. I don't have like this for the main one. We should probably though say not the syntax rule set path, but syntax rule set source, and this should be like a function which either returns the one that is read at compile time or somewhere else, you know. And same for like the main cast, I suppose. Maybe. Well, I mean, sure. No. I think it's okay. You can. I just like it's just not should not be the file contains all the file read at compile time. I think that is wrong. Like a file containing all of the built-in syntax definitions, that's okay probably, right? And that would probably live in what, like in the syntax, like in one of these files. I don't know, or maybe like you can have like the default syntaxes and stuff, and that would contain the minicast and the stuff. Yeah, sure, you can do that. Yeah. If you also make it so that it actually reads at runtime instead of at compile time, if the environment variable is set, which is like, I don't know what variable, like cast dev source something, which is going to be just set in the flake to be the current working directory. Because right now I need to actually recompile the LSP to pick up the syntax changes. And the standard library is going to be embedded in the binary too, I suppose, sometimes. But yeah, like in the bootstrap, there is the cast std environment variable, which if it's present, then it reads it at runtime. Otherwise, it reads it at compile time, the embedded standard library. Too. All right, anyway. I was doing this, right? So t is not found here, right? Because this t is this argument, right? We need that to work. Right. So I want to say right here, type not found. This one, right? But this should be, oh, this is like current context type names. I feel like, yeah. How about we say like look up yeah, actually, yeah, we need to do this. We need to basically look up type name. There you go. That's what we do. That's what we return here. And we say look up type based on name. It should return the type, which is going to say that if it is contained in the like type names that we know about, then we will just return the named name. If we have not found it, then we will do the diagnostics that this type is not found, but we will also try to find it in the current something else, you know, if you know, current template args template args by name. Is that what I want? Maybe. ord set ord map get name is some type. Then we just return this type. Let's say template args context. Do I want to like give it the template args? Sure. Maybe we have like, so this is like the flat array, and then we have also by name, which is going to be a map from string to the type. Sure, let's do that. So when we compare, we just compare by this, right? But over here we have list, and then I also want to have by name. Over here we know the arg name is template arg names at I. So I want to say by name add arg name, and this is the type. Argument, which is the type. So we have this, and we have by name, right? And when we instantiate over here, I do have the template arguments, right? So I will just say when I instantiate, I will say with template args context is equal to the args, basically. Yeah, I think that should work. So now I should be able to look it up, and we will like resolve it to the alias actually, which is the actual argument. Right? Yeah, I think so. This needs a return. Oh, because this is a reference to a type, I need to give. Yeah, because this type is a reference, right? We need to dereference it. Which maybe will not work. Eventually. Token span. What's the token? Oh, lookup type. I need to have the span here, right? For reporting the errors. Lookup type name. Token span. All right. That's only there, but yeah. Okay, imagine if it's just going to work here. Type shape unwind is not unwind type. Because I need to not do the semicolon here in the end, of course. Did it not pick it up? It still says that it's thinking that I'm returning unit here somewhere. Where? Oh, because we need to not report. We need to report and unwind. That's right. Yes. Because this actually returns the unit, right? Because we don't know what to do here. We're going to unwind. It's compiling. All right. Cannot read by name. That's right. Yeah, that's right. Because by default, the template args context is actually like empty. Right? Because yeah, this context is optional. It's not always there. So I should say that by default, I should say by default, when I'm doing the compiling, right? Similar to how like I create the empty scope, because we do name lookups, right? We similar to that say that template args context is also going to be this, where we have the args is release new and by name is word map new. Otherwise, the context is not present. Let's have the comment here. Outside of template instantiations. So menacing. What is so menacing, Robert? You are? Am I? List index is not found in the current scope over here. Right. Because we don't have like, okay. Because this is a template, we need to say list index of member infos. There you go. It should probably be a different error message, right? Because it's trying to look the name, but it's a template which lives in a separate namespace here. Okay, and then temp 59 is not iterable. Hold on a second. So it actually compiled, but then it cannot run. Let's take a look at the compiled code. Say temp 59 is dot members. Oh wait, but what is members? Oh, what is members? We say members is this, which is these members, which is these members, when I initialize the type info for struct, right? So what is the members here? Members. Members is this, which is this, which is allocate a list of list members, right? Shouldn't this be a list? That's what I return. It's supposed to be a list. Do I use winit for linksider? Yes, I do use winit. Did you find a bug in winit? Or something? Members? Nice one, Robert Pattinson. Nice one. Nothing is wrong. Okay. Wait, so why is this not iterable? So we're trying to allocate type on heap. 1059 is not iterable. Yeah, but what is it? How about, right? It's because we need to, yeah, how about I like initialize type info for struct, right? Yeah, it's like this over here. How about I try to native console log members. Let's do that. You have a WinIt program. Do you have a more than 60 hertz screen? Yes. I have 144. You have a WinIt program that runs on 120, but you only need to render at 30. You wonder what the closest way to do that is? I have not been doing that myself. But you're supposed to, I guess, like insert the sleeping yourself. There's probably a crate for that. If you want to use it. Or you can just sleep yourself. But like that seems hard, right? Yeah, I remember I was implementing these sleeps at some point. I don't have it in Linksider though, but I remember doing this for another thing. Right. Like not super obvious. To do that. That's right. Rust crate for FPS limiting. You know? For the Rust languages, developers looking to limit FPS, the game loop crate is a lightweight choice. For implementing frame rate independent game. No, that's not what you want. You want to limit the FPS. FPS ticker. Cabin FPS causes mouse lag. Oh, that's in the game Rust. Here's the IGUI issue about the limiting the FPS. I'm just using these things, but yeah, I can see how sometimes you actually want to frame limit. That makes sense. Like in some games, you want to, for example, frame limit the UI rendering because it's more difficult to calculate in the actual game. I might want to do that in Linksider for some things. Eh, if I ever get back to it. I will. I don't know. How can I write a WinIt application a stable frame rate? This crate provides a struct for keeping your game loops running at a certain FPS. FPS clock. You just do FPS clock and then you do the tick at the end of your game loop, running your game. Yeah, there we go. I found it. Right. You can like look at the implementation though if the implementation here is good. Because you don't want to just like sleep too much sometimes, right? It needs to be like. Let's see. They just have the last tick time. Last time you ticked the FPS in nanos. Yeah, they just literally just sleep for the duration, which is the difference. Well, I mean, technically this is, I suppose, good enough, but I feel like there could be a better implementation. But this should probably work, especially if you want to limit at the relatively low FPSs. Like 30. But yeah, I mean, you just measure the time since the last tick, and then you sleep for the remaining duration, if needed. Right? I think I was doing something else when I was implementing this myself, though. Don't remember. Initialize type info for struct. Wait, that's not what I'm doing, right? I'm having main, and then I'm calling the generic function, generic type, which allocates on the heap. Wait, no. Yeah, we have the generic type, so like this is supposed to be called, right? This is console log. Okay, so it's before I do the console log. It's when I'm trying to allocate the type info itself on the heap. Okay, got it. Got it. Okay, I see what's happening here. It's because the type info, right? We want type info. This is what we want. Type info is this, which is not exactly correct, right? Because we want the details, and there is no nothing here, right? Because so we have like we have this type info, right? Built in, which is supposed to initialize this for me. If you just wait the difference, you're too late. No. Um. Yes, which is why I was saying I was doing something more than that, right? But I don't remember exactly. You can look it up. This is like a well-known problem, right? How to properly limit FPS. FPS in games in C. Let's say C. And also you don't want to potentially you don't want to have the input lag, which means that you still need to like process the input while you're sleeping, technically, right? To figure out like the time at which you clicked the button, if you need that. I mean, you can probably look it up yourself. Yeah, but yeah. Not a game summon input lag, not an issue. It's probably not an issue that you will like sleep for too long though, too, if I was to guess. Right. Also, maybe you just like calculate the like. So basically, you don't just like see the time since the last frame, but also like the frame before that, right? How like did you sleep for too long, basically, and then you like compensate for the previous frame also. Something like that maybe would work better so that you don't oversleep. Okay, I need in the compiler over here to have the type info, right? So type info is creating this like constant type info, which I only, yeah, this over here, I commented this out and this doesn't work, right? Because I need the members to be, and this should be the list, but we don't have the list. Members, what is members? This is the array list, right? And the type is a list named member info. Instantiate root. I want to instantiate the template name and the arguments. Arguments. Like maybe this should be not instantiate, but like parse instantiate. And then we have like the actual instantiate, right? Because this is a little different, you know? Instantiate is the thing which has the template name, which is a string, and then has the template args, which is the let's say list of types. I think that makes sense, right? And this should be part of the instantiation. This is where we do all of this code. This one just as the parsing, yeah, but I need in these arguments, right? Yeah, the list is just going to be the args, I suppose. We just have the args here. We just calculate them by name here too, right? Okay. And then over here we say something like if args, let's see, args length is args length, and expected args length is template arg names length, right? So if args length is not expected args length, then we're going to do diagnostic, which is going to be only a single diagnostic then, right? Which says expected template expected expected args length args, but we got args length like this. So we report this and unwind. Otherwise, we just say over here for I and for I and arg in args iterate enumerate, right? This is where I just need to add it to the by name, right? And yes, the arg name is this, and this stuff is different. This goes into the actual parsing of the instantiation. So we have found the template name, and then I go the args, right? Say that args is array list new. All right, so in the end, we just instantiate the template name and args. That's what we return. This diagnostic is not needed. This diagnostic is not needed. Right, we just say that args push back parse type arg. That's all that I do over the trailing and the commas and everything. So when we do instantiate now over here, this is the parsing, right? So this parse instantiate. So here is going to be parse instantiate. And then when I do the type info, I want to actually instantiate the list here. This, the members that I want. Members, right? Yeah, so we don't have the type and the expression called list. So this type I feel like we want the instantiate this returns instantiation, right? I can like it's okay. Type info. No, it's not okay. Let's do instantiate, right? I want to specifically instantiate type, right? Template name args, right? This is supposed to return the type, not any instantiation. Okay. But then I need this pen here, kind of. Doing this pen so that I can report the error, of course, right? So we instantiate, yeah, we like match instantiate template name and args, right? And if this is the type, then return the type, and if it's a function, with diagnostic, right? expected type, but this template expands to a function. So we do the type info list over here, right? This type is supposed to be instantiate. It's supposed to be instantiate the list, so we must have the list as be present. That's the template name, and the arguments is let's do single element list with named type info, right? It's a list of type infos. Wait, no, it's not. Hold on. What was here? Runtime. Members. It's member info, right? It's a list of member infos. There we go. Single element list. I have like a macro which allows me to do this with any amount of elements. Primitive. Oh, it's not primitive, by the way, right? I need to see if this is like this type can be a native type, I think. Native. I feel like the native types. No, we don't know what they are. And what is this needed for? If a string starts with the array, then oh, but we don't want like the inner stuff. Okay, interesting. I definitely don't need to treat them as primitives in the JavaScript other ways, but I need to know the information about the inner type, which will lose the ability to do that since it is not the primitive type now. It's not like the built-in type, but it's done like that. So I would need to do something. Well, we can do something hacky, I suppose. Now let's fix the other thing first. This over here is not the list of members because we cannot have this expression, right? We need to have a native expression. Native expression. Native expression has parts, which has a raw or interpolated expressions, right? So yeah. let's say here, parts. We're going to push back raw opening bracket, raw closing bracket, and then we're going to add every single member, right? So we have the members, which is the, yeah, it's the list of expressions, right? So do we just say that for member in members into iter, say parts, push back, interpolated member. And then we also add the comma. Right? Let's try that. Couldn't find template in scope. Hey, it's not template span. When I instantiate, I need to know the span. In this case, the span is going to be a root span. When I instantiate over here, this list with member infos, what's the span? Because we have the type info of the type, right? What's the span here? Oh, it's like a special in this file. Okay. Yeah, let's do that. Okay. Bum 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 bum. Instantiate. This requires a span. Args.span. No, we just have the span here. Find root in scope. What is this? This is instantiation, right? Yeah, we just say span. We set the top level definition span here. Okay. Root span. Instantiation at span. Boom, 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 boom. String is not type. String is not type. Oh, because yes, the instantiation, should this be a type? It returns a name. Yeah, because over here we have the type, and this is type name, right? We need to return named type, right? Yes, they are also going to be named. Could not find type in scope. A named type name. Would you say that Kast is superior to a camel? Currently, maybe probably not. It's superior to any of the existing languages that are usable. In the future, absolutely. Superior to every other language. Well, the only like issue right now kind of is the compile times and the error messages. Technically, I would say it's kind of already almost better. I mean, we don't like have some features implemented like the exhaustance checking, for example, is not implemented, and exhaustance checking is not difficult to add. I just don't want to work on it right now. I want to self-host first. It's kind of okay without. AST is not list. I'll say Steam. Rust has the best error messages. I mean, there's probably other languages which also have good error messages. But I think the reason why OCaml error messages are worse sometimes and Kast are worse sometimes is because of the inference algorithm that we use. So I want to change the inference algorithm, I think, a little bit when I do the self-host. Not too much, no. But like, yeah. I'll need to think about it a little bit. I'm just using the unification. Hindley Milner. No one uses that really. But I mean, since everyone is saying that, then I might also say that I use it, right? Yeah. No one is really using Hindley Milner. Everyone is using like some modification of that. But I guess like one of the biggest parts of the Hindley Milner that is, I guess like OCaml is closer to Hindley Milner because the let like the generalizations of lets. Is it called let polymorphism? Like that's what I don't do. Let polymorphism. Which basically like OCaml, if you see code like this, you say like let f(x) is equal to x. What's the type of this, right? The type of this is basically going to be for all a into a, right? So it automatically creates the implicit like generic argument, and that's something that I don't do. This is what's called the let polymorphism. We instead do the explicit stuff currently. Although I think I might want to do a form of this similar to how Rust actually does do this, but only for lifetimes. And when I do implement the lifetimes, I might want this because otherwise, always explicitly stating this is a little bit too annoying. Although in Rust, it doesn't really do the let polymorphism. It instead is doing the implicit insertion of the lifetime arguments based purely on the syntax. But the way it is done in Hindley Milner is a lot more complicated, and it is conflicting with a lot of other features. So in general, I consider this a bad feature. Let polymorphism is bad. There is this article called "Don't Generalize." Don't generalize your let or something. Let should not be generalized. This thing is the paper by the Simon Peyton Jones, which is the creator of Haskell, right? Which argues that the Hindley Milner approach to the generalization of the local let bindings is bad. Because if you want to have more complicated language features, then let polymorphism just gets in the way a lot. It doesn't bring a lot of benefits, it only brings problems. Well, not only problems, but mostly problems. You can just sometimes have the explicit annotation. And like when I'm writing OCaml, I need to do the explicit annotation like 5 times copy pasted anyway. Because like, even although the OCaml inference is good, it still cannot figure out like anything that I write. And I need to do explicit type annotations anyway. Especially like when the generalized, the GADTs are involved or some stuff. Next, Kubi has to release a paper saying that compiled time metaprogramming is bad. Hello, Brainoid, by the way. Hi. What am I doing here? Bum, 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 bum. Kast seems fun. It might attract a lot of furries. I don't know if you want that. Well, I mean, we need to attract someone, right? I'm going to add a minicast logo to Twitch emotes. I don't know. Maybe minicast is better than Kast. Minicast is like getting closer to like, I don't know, like especially once these templates are working, it's almost like C with templates, which is not like the C++, but you know, it's it's a thing. It still is a simple language even with the templates, right? Right? I don't plan to add any like safety features though in minicast, so that for that reason it's definitely worse than Kast. My bottle. I'm sorry. I'm just used to placing it there. Those members. Hold on. What's the error message saying here? It's a little long. It's a little long. What's the member? Yeah, this is expressions, right? It's native parts. You got today's Wordle. Type is not instantiation, right? Where? And we don't know where. Yeah, because type returns. Yeah, we want this instantiate type. There you go. There you go. Now what? Did not save yet. Instantiation is not type. Right. Let's keep guessing where the error is. Do you not care about ligatures? I do use ligatures. I do like them. There's only a couple though that like matter, like the arrows basically. the only one that matters, right? I guess the equal is also like gets like into a single thing. Or like a not equal looks like this. Essentially a type. This returns a type, right? Right. Single element list. Named member info. Native parts. And these are just raw. Well, we have something in the instantiations which is wrong, right? Instantiate type. Do I use this in other place? No, only here, literally. Let's comment this out. But I don't use the instantiation here, so it doesn't really matter. Let's try commenting this out and saying type is unit. Just to like understand if it's happening there or not. Maybe let's try recompiling from scratch. Maybe I broke something. We're doing no comms past the game challenge for LD. Nice. I'm not sure if I want to do the LD. How much time is it? Like, it's been not too long since the last game jam that I have participated in. 6 days. Yeah, I don't know. I'll think about it, but I think I will not participate. And pass the game means that you like passing the code and stuff, right? Yeah. Which means that you all need to work in the same engine or something, right? So I'm definitely not joining you in that. I don't want to learn Unity or whatever. So this actually compiled, by the way, yes. Which means that maybe there is something wrong with my incremental compilation after all. Let's try this again. Just recompile. Yeah, because it says that this was changed, but it was not saying that before. Yeah, it compiles. Yeah, my incremental compilation sometimes break. It's okay. Minicast is written in Kast. Yes. Yes, this over here on the screen. I have been writing like only Kast for the last like week or like more than that, maybe 2 weeks. How much? I don't know. The Kast self-hosting after the minicast. We have 15,000 lines of Kast code here already. This language server, which is like just showing me the hovered character and syntax highlights and the formatting, this is already self-hosted. I'm just adding the minicast as the intermediate stage, which well, it's written on the screen, right? We bootstrap to minicast first. So we self-host in the stages, right? We first self-host the minicast and then we self-host the rest. Because right now the transpile JavaScript that I transpile directly from the bootstrap is relatively slow, so we will add the C compilation target instead. And instead of transpiling cast to C, we transpile the minicast to C, right? Which we can already self-host. So we will write the C we are writing the C transpiler in Kast, and so that we don't need to rewrite it later and stuff. And it's just in general easier to transpile the simpler language than the Kast itself. It's like an intermediate representation. language here. Okay, it actually works. Okay, it actually works. It actually works. There is no way. Okay, nice. Now will this work in C? Let's try C. Probably not. Unexpected top level item over here, right? Okay, at least we are going to get rid of this. Okay. So expected this. Okay. Here's what we want. In order to index into a list, right? So we represent lists in C as the data, which is a pointer to T, right? I mean reference to T, but reference in C is just a pointer, right? And then we have the length, which is size T. So when we allocate this size should be like size T actually, right? And the index, should the index be size T too? I don't know. Nothing will like type check, and I don't have the conversions yet, right? And I don't think the conversions belong in the here. Okay, so we have native list dot data. So this gives me the pointer, right? And then we just do the indexing at the index like this. And this should return the reference, which returns the pointer. So we do the reference here like this. The address. Okay, and then we allocate the list. This is going to just be the... This just needs to allocate the list. All right. So I need to return the data and length. Let's call this length, right? We don't have the shorthand syntax in minicast, which is going to say data is data and length is length. But data is going to be the malloc, I guess, right? We need to malloc. We need to malloc length. Wait, isn't there like a dedicated stuff where you allocate the array, which is called calloc? Calloc is also zero allocating, right? Allocates memory for array of number objects and initializes all bytes in this allocated to 0, right? It's just weird that like malloc does not have the size and number, and calloc does do that. Even although you just like 0 allocated anyway. I do not want to initialize the bytes. Is there a reason for this? I don't know. If allocation succeeds, it returns a pointer to the lowest byte in the allocated memory that is suitably aligned for any object with fundamental alignment. Wait, but what's the size then for? What's fundamental alignment? Let's just do malloc here. We just do length multiplied by I need to have the the size of this type, right? To do the malloc. I don't want this size of to be the built-in thing. We do have the type of the type info, which gives me a lot of the type information, right? T type info is just type info of T, right? And then over here we just allocate a length multiplied by T stride, right? So we have the strides of the types, which we are supposed to use here, and we don't have the multiplication, so we should like say this multiplied by that, right? Is that all that I do? We never free any memory currently, and that's okay probably. Expected boolean got size t over here. Greater. Wait, why is greater returning size t? Boolean. Reference does not have any fields because member gereferenced. Expected int32 got native size t. Yeah, because add. Oh wait, add is not even defined here. Const add. A size t, b size t, size t. A plus b. It's going to say that we have two things. Yeah, we have like two runtimes, right? Yeah, that's okay. I feel like all of these should be maybe like, I don't think we wanted to have the namespaces in minicast, right? So should this be, you know, all of the items here should be prefixed basically. You know, all of these things should be prefixed, you know, minicast underscore underscore member offset or name, you know. Is that what you do in C? When you write C code? Right, that's what you do. Do you do two underscores there? But if you look at raylib, well, you just prefix everything with array then, right? But we prefix everything with the minicast. Wait, no, it just says init window. It doesn't even say array init window. Why don't they do that? Isn't that going to like collide with some other symbols if you use other libraries? Huh? You know what? I don't know. Or do I add the namespaces? Adding namespaces is not too difficult. When do I stop adding stuff to minicast, though, if I do that? I just should add this, add size t, you know, and mul size t, and greater size t, because we don't have generics, right? Although, wait a second, we can have the add actually as a generic thing, and then I don't need to specify it twice, right? This actually will work. Yeah, that will, because I have implemented this now. TTT, TTTTT, greater, and then this can be like actually that. This returns boolean. We round up. This can also be that, and then we will automatically create different things. Remember, add has and now we don't need this. Add sub less. We don't need that anymore. Mul. Yeah, but I need to now specify multiplication of the size t as this, right? Because we don't infer the template arguments, and I think I will not implement the inference for it. Div round up size t. Greater size t. I should say that it's found, but it's okay. Hold on, not found in current scope. Yeah. How about over here? I will say that find identifier type, right? If it is yeah, if context templates get name is some then it's not like it's not found, but it's instead name is a template cannot be used directly, right? Or something like this. So that we have a better error message. Right, so add is a template. Over here, when you say add size t here, initialize, offset, or name field. JavaScript runtime. Initialize, offset, or name is just like this function, which should return member offset or name. And because this is the size t, we just initialize it to 0 here in C, because it's going to be calculated later. Yep. Okay, number literal cannot be size t. Yeah, because we allocate list. Yeah, because should I like allow the number literals just be like converted to strings? I don't know. Because otherwise, how do I type check it? And list index, like that's why we do the list index as the int here, I suppose. Doesn't really matter though. Okay, so we have this details members. Get member generic type of t details members, right? So yeah, because in JavaScript we have the details, but in C we don't have the details. Let me see, C runtime. Type info, right? We just have the members here directly. I should add the detail. And the reason it is different in why is it different in JavaScript actually? The representation of the type info is just like, because this is a tagged union. So it's super primitive. Object or array. Let's also make this closer to each other. I mean, we can have a function get members instead of like accessing this directly through the details, right? Get get type members. We will have the type info, and this should return the list of member infos, right? So in case of JavaScript here, we just return type, details, members. But in C, we just return the members directly. Okay, so instead of saying the details members, we say get type members. Let's say here, let members, this get type members of the generic type of T, right? So we get members, member number 0 here. Pattern match non-exhaustive over here. What is this? Calculating expression. When we do a let. Oh, I cannot transpile let to... I cannot transpile let into C right now. Okay, let's fix that. I should probably commit, right? I've done a lot. Templates in minicast, mostly. Now I'm just like testing it. So apparently we don't transpile the let. Yeah, because this is commented out. So we have a let name value. In minicast, we can only initialize a single variable, right? So this will actually return void, but we need the we need to insert statement, which is it a let var here? Yeah, we just let var. We need type, identifier, and expression. We need let var, identifier name. Type of this is value type, right? And the expression itself is just value, is pure calculate value. I think that's it. Maybe not. Semicolon is unnecessary there. I think it's not going to work with like the type info is not generating in JavaScript. In C, only in JavaScript right now. Right. Okay. We also need a reference. Okay, actually, yes. Uninitialized also. How do we do the uninitialized? We need the uninitialized. Is this? Do you have like a dedicated instruction to create the uninitialized temporary variable in C? Or do you need to just not initialize a variable? Can you even have that? Not sure. But if we have a reference to place, then we just calculate place. All right. Calculate place. Place. Calculate place. What calculate place gives me the place, which returns a pure expression, right? Which is going to be the expression which is pure, which we can use on the left-hand side, actually, right? Right. So we are going to return the. Do we have in the cast the reference? We don't have a reference, right? So to generate C, we need an expression which is called. Well, you don't. It's not called references in C, right? It's called address. Is it called like C reference? C operators. What do they call it? Do they call it reference? It's called address of, right? And this is called indirection. This is not called dereferencing. Is that what I should call them? I mean, it doesn't matter what I call it, right? In my cast. We can still call it a reference to expression. And we can have the deref of expression. I think that's okay. So if we have a reference, to expression, we're going to write a reference, and then we're going to print expression. And then if we have the deref, and we print this star and then expression. Deref pointer. Okay. So when we have the reference, we need to calculate the place. We need to get this. This gives me the pure expression. Yeah, we just need to do pure, right? It's pure expression like this, but then we need to have a reference like that. There we go. Well, I mean, the reference to the thing is actually still pure, right? So I don't need to calculate anything here. So I can return pure, because reference is still a pure expression, right? And then when we do the deref, this is where I need to calculate expression, and this is the this like, well, this is going to be a pointer anyway, right? Reference, calculate reference. Reference is this. So get is expression is some deref reference, right? It is pure. And then set is value into insert statement assign assignee that deref expression is some deref expression. Seems like this could be like extracted. So we assign to the reference expression the value. Pattern match is not exhaustive. Again, we have the record. Okay. It seems like I barely did anything in C, right? But which is what we were supposed to do today before I went into the templates. We need to have, yeah, we have like the context too, which let's not do that. Index is also not present. Uninitialized, variance, assign function, records. Okay, let's do the record. So record is the thing that has the fields. Right, so this is supposed to tell me the record, right? Do we have in C it's called compound literal, right? No, compound literal is when we like annotate it with the type, but sometimes we want to not annotate it with the type. Well, is there a reason for me to not use compound literal? Like this is just having a little bit of the extra type annotations, even though I already have this type annotation on the left-hand side, right? And this is going to be okay then, right? I can just have the type annotation present twice. Right? Yep. So I want to return the compound literal with C with all right. So we need the type, which is convert type expression dot type, and we have the value. Now we have fields. This field initializers. Field initializers for field in fields. Iterate do. Wait, what are these fields in the records? Over here. Record is just a list of fields. Just have name and value. There's a string and expression. Okay. Field initializers. Push back field. Field is name is field name identifier. and value is pure calculate field value. Is that all? Is that all? Enum is... I'm not sure if I'm using that yet. Can find array in scope, array list. There should be a reference. Still not exhaustive. Oh, I am actually using the assignments. Okay. Okay. Assigning. Okay, we have assignee and we have a value. Assignee in the minicast is a place expression, I think, right? And let's see. Yeah, assignee is a place expression, value is an expression. Okay. So in this case, we are actually going to return void, but we are going to say that assignee is calculate place assignee, right? And then value is going to be pure calculate value. And then we're going to say assignee set value. And that's it, I think. And of course nothing compiles because I again did the semicolon. Pure doesn't have expression. Okay, we are having a panic. And I would rather have this a diagnostic so that we know where exactly is this happening. But this is, yeah, we have three panics here. So when we say pure, maybe let's say that pure should still have a span, so that in this way we can report the diagnostics. Yeah, that's right. Right. Oh, we don't have any diagnostics in the C transpiler. We only panic. Okay, got it. Let's do the diagnostics over here. This expression is void. Like it is void and cannot be used as a value, right? And then we have span is pure span. Okay, what about the other panics? Cannot assign to a temporary expression. Let's do the same here. You mean the diagnostics. which I think. Oh no, yeah. We have the expression here, right? Yeah. We want to write that cannot assign to temp expression, temporary expression. So span in this case is going to be expression span. Okay, and what else do we have? Another panic. Main must return the unit. Yep. Let's do the diagnostic here too. Main must return this. Function definitions don't have these spans though. So what's the span here? I should probably have the spans in the definition of the functions though. That does make sense, so we can like refer to where the function is defined. Why not? So the function definition will actually have the span. Let's have the name span, because like that's what we want to refer to, like, right? Not to the whole function, just to the name. It's probably okay. So this would be definition name span. But then in the compiler over here, function definition, right? Parse function definition. That's what we want. Oh wait, some of the functions are actually anonymous, so we cannot do that. We'll just say span. It's okay. Maybe I can improve that later. Span is just definition span. Okay, so when I say void, I still need to say the span here, right? To initialize this pure expression. Void. So we don't do void. We say void our expression span. Like that. Here, here, and here. And all over there. Everywhere. Over here I'm returning this, and say span is expression span. Same goes here, and return expression and span. And over here we have expression and have span. Okay. And this is what? Calculate literal. Literal. Let's have the span here as the argument. I still have some weird expression. Dot expression. Oh, it's over here. Right. Yes. Let's just say span is the expression span. There we go. So we need to return expression span. There we go. Expression span. Expression span. Span is not found in the scope. Wait, what? Let's import. Couldn't find output is scope. Yes, we need to import a span. I need to import diagnostic and output. At least. Here's another one, which forgot the span. Okay, compiles. Progress. This expression is void that cannot be used as a value over here. I mean, yeah, that's right. This cannot be used as a value. Why is it trying to be used as a value? Because because I am. Wait, what? Why? This expression is a void and cannot be used as a value, right? Because this is assigning, right? So basically, the result of this is void, and I'm trying to embed this, right? Yeah, that makes sense, right? Because we have the native expression with interpolated parts here, and this must be expressions right now, right? Yeah. And this needs to be like put inside of this block, which is inside of a native expression. So yeah, how do I do that? Also, this should be a statement, not an expression. But that's another thing. So yeah, the problem is that I'm trying to put it here as a value, but we are in this case interpolating, not a value. Maybe I cannot write it like this. Or we need to like have a different type of interpolation. I don't want it to be too complicated though. Here. I can, like, if I extract this into a function, then this would work. Maybe, right? Sure, let's do this. we're going to initialize a single member, right? Initialize type info member for struct, which we're going to call here initialize type info for member for struct, right? So this is the member, but I cannot do like the let's here. This is the annoying part, right? Like I can, like, this must be an expression here. It has to be, and which means I cannot like do the temporary variables here even, right? I just need to say basically what we have here. I think we need to give it t members and I, which is a native one, because that's what we do, right? There you go. Because in this case, this is an expression on which we can put behind that, yeah. So, and this is going to be just regular code. We're just going to say that member is, so we have like all of these arguments plus the I. I guess later this is also going to be done as a closure instead of a separate function. So we need to copy the arguments. I'm just going to say over here that I is size t. So we get the member, and yeah, the member, we are setting up its offset, and we are updating the size. Okay. Expected int 32 got size t. Where? Oh, because list index actually takes, let's do size t here. It's okay. Right? Just if I do the size t, then number literally cannot be size t over here, right? Because this needs to be like that. A number literally cannot be size t over here either. This is okay, probably. This expression is void and cannot be used as a value. Oh no, initializing is a void. Oh no, wait, what? Yeah, wait, this still doesn't work because this function returns void. Why that? Okay, you cannot do in C an expression in any. Yeah, an expression must result in some type. So how do I write this? I can also like do that if I interpolate something that's void. Also, technically, when I interpolate, I try to evaluate it immediately, which would be like outside of this for loop anyway. Most compilers support the extension for the expression blocks. Yeah, but can you have the expression block which results in void? I don't think you can. You think so? Let's see. Let's try. Let's try. We're going to say that over here, something like. Well, we're trying to do like for loop. Oh, it's just like an expression, right? This, and this is what. Wait, but how do you like? Wait, what does this even mean? What does this even mean? So I can have like void foo, and I can like call this function foo here, right? No, expected semicolon after expression, right? Like this. That's what you mean, right? We can do this. It just returns the last expression implicitly. It does not. It seems not in the clang here. It doesn't even like parse correctly. But you can do this, and this is like supposed to be an expression, I suppose. What does this mean? Where is the documentation for this? Like, if I say, you know, int x is equal to this. Initialized using int with an expression of a compatible type void. Okay, this expression actually has type void. There is no way. You can have expressions of type void. I mean, I guess this is the same error as over here, right? Can I say void y? Variable has incomplete type void, right? No, you cannot. You cannot store it in a variable, but you can have an expression of type void. Is that right? But this does not work. C embed stay block in expression. Like what is this even called? What is the syntax even called? C block becomes expression. You have statement expressions. A statement expression is a compound statement enclosed in parentheses, which allows it to be treated as expression. The value of the entire block is the value of the last statement in the block. Oh, wait, hold on. Oh, you need the semicolon still, right? Wait. Are you saying that, like, you say over here 1, 2, 3 semicolon, and this is going to be 1, 2, 3? Oh no, there's no way. Yeah, I think this actually does solve my problem. It means that I don't need to actually make a distinction between expressions and statement when transpiling to C, technically. There's just like this problem where when I'm interpolating this, I'm putting the... Yeah, when I'm interpolating, I'm technically like calculating this outside of the native and then putting this into a variable and then putting the variable here. But maybe I should just change the way my interpolation works, and I should instead have the embedded statement expression. In which case, even my previous code is supposed to work, I suppose. Right? So I don't need to extract this into a function. We just inline this code. Right? So, yeah. But I think I will only do this in the interpolation specifically, because in interpolations, I will do the expressions. If that makes sense. There's also a common cleanup extension that schedules a function to be called at the end of the scope. Schedules a function to be called common cleanup. C cleanup. Cleanup a variable attribute. Is this like the defer in C? And it works when you are like returning early too, right? Then, because otherwise you need to do like a go to the end where the cleanup logic is, or something. Where you're you're cleaning up the variable specifically. Wait, is it like scope local? Because the variables can be specified in a scope, right? As the variable goes out of scope. It's not even when you're doing the function, right? Interesting. You actually have the defer. You actually have IE in C, basically. Kind of. Okay. I want the interpolated. So like over here, I'm doing the interpolated, and I'm doing over here the pure calculated expression, but that's not what I want. Right? Because in this case, we want the statement expression. Is that what they call it? Statement expression. Right. So I guess I'm just going to have the expression, which is a statement expression, and statement expression contains a block, basically, right? Okay. Okay. When we print it, I'm already putting everything into parentheses, I suppose, right? Anyway. So we just have the expression, which is a statement block. I just print block here. And that's all. So over here, I need to like create this block. When we're having the interpolation, I'll create this block. I will calculate the expression, and then this is the result of me calculating the expression. And then I see that if result expression is some expression, some like expression, because this means that it's not a void, then I need to also add it as like the last statement, right, to this block. Right, so then we insert statement expression statement, right, as the last statement in this block. And then we'll just say that true, this is an expression, which is a statement expression with the block. Okay. Let's see if that works. I'm using like, so like on these features though, they're not implemented in every C compiler, right? So I'm relying on some of the extensions, but it's probably fine. It's probably okay, right? This one lasted for an hour before we ran out of RAM, so which is not too bad, I guess. And in the last hour, I actually spent 5 minutes compiling. Okay, and 55 minutes writing code, I guess. Okay, let's see. Pattern match is non-exhaustive over here. We have the, yeah, we actually have the uninitialized. Okay, what do I convert the uninitialized into? Wait a second. Can you just use the wait? So if we have the statement expressions, then we can just say that because like I'm writing explicit uninitialized, right? Int x int y is uninitialized, but you cannot have this in C. But what you can do is you can do a statement expression which says like int u and u like this, right? That's cursed though, but it does work. C explicitly, like C uninitialized expression. Is there such a thing? I mean, we can also. Yeah, I think this is okay if I do that. But we can detect if I just initialize a variable and then I don't initialize it and I just declare it then, right? But that's like for cleaner code generation, right? Yeah. So let's actually do the same stuff as I'm doing here, right? So I'm going to have the block. I'm going to have the block, and I'm going to say that. All right, let's match the I don't know, let's say if type is unit, return void. Otherwise, we create the block. We say that let var, yeah, let var is new ident uninitialized. We say let var insert statement let var type is convert type, the type value is none. This is identifier, and then we insert statement expression var identifier, and we return the statement block, right? Yeah, but I can also like actually let's actually generate this. When we say let over here, we always say the let var, right? But if the value over here, this expression, right? I can say that if value shape is uninitialized, then we are going to do the other thing. Yeah, how about this? Then we just insert let var type is value type identifier name and value is none. What to do with fatal error exception? Cannot wait function to be compiled. Try to do less compile time, I suppose. Like you're trying to do too much stuff at compile time, which I need to fix maybe some things for it to be possible. Although I mean, you're trying to do something at compile time, I think, which is not compiled yet. You're trying to call a function at compile time, which is not compiled yet. That's what it means usually, right? I think it's pointing you to the place where you're trying to do that, or is my error message not including that? It's called ident not var. Pointing you to the invocation of a const function, yeah. But it is compiled. How do you know that it's compiled? If it was compiled, it would not be complaining. It's a const function inside of a module, not generics. It doesn't mean that it will be compiled though, because in order to compile a function, you need to resolve the symbols, and yeah, it's mostly about resolving symbols, I guess. You can try reordering some things. Like because it's inside of a, like you're trying to evaluate something at compile time inside of a module, right? And this and the function that you're trying to do is defined in the same module, which means that but it usually means that you can only use this function after the module is closed, because only then we know that some symbols are not referring to the symbols inside of the module, right? Because the modules are recursive, we cannot just like resolve the symbol immediately outside of a module, but still inside of a different module, maybe? I don't know. Or maybe you're doing it like as a const value, because I think that also sometimes doesn't work. Like there are some things that are supposed to work but don't right now, just don't get awaited. I don't remember the details. Anyway, I have compiled, but then it says that we have unknown name. Let's take a look at my C code. We have generic type of int. Right, because this... Wait, what? No. It should say struct over here, right? Because we are using the forward declaration here. And to do the structs, when I define the type of things, okay. All right. Well, we have some generate some code. This is an identifier that is not done. And then we need the right. Like I can go to the definition, but the C compiler cannot compile it still because LSP knows about it, but not that. Okay. We need forward declare, which means we need to struct it. I think it means that it's when I convert the type. When I convert the type, this is a named type, right? But if this is a struct, then I need to say struct name instead of just name, right? Not for the unions or enums though, right? Those need to be just defined earlier. right? So I need to like find the actual definition here and do something based on this. We have the program. Context program. Types. Get name. Unwrap, right? And this is the definition. And then we say that if definition is struct, then it's going to be struct right. We have a we have struct ident. That's what we need to do. Hello, Supercuber. I've generated some C code, which almost works. This example that I'm trying to compile is the is this generics, which we will like do some runtime times type stuff with the generics eventually, so that we don't monomorphize. Although now that I added templates, we can actually also do the monomorphization easily too. So maybe I will not do that yet. We'll see. Not sure if this will actually like work with we need to test the templates more. Field has incomplete type, struct list member info. Wait, list member info members. No. This doesn't work. So like I'm trying to have so this is a list, right? A list is technically like this, pointer to data plus length, right? But this needs to be defined earlier. This needs to be defined earlier. Wait, I what? No. I was trying to do this, right? What? Did I not top sort my types? Make sure all are defined for the type when I'm creating the type definition. Oh, right, because when I have a reference, I don't need the reference to be defined actually, right? Because this can be forward declared. Anything else needs to be forward declared, but when something is behind a reference, we don't need to. Maybe, do the function arguments need to be forward declared? Probably not either, right? Or, yeah, probably not need to be forward declared either. And function result type. Because you don't store it directly in this type, right? So I just need to not to do that, literally. This can be inner type can be forward declared for pointers. Let me check. So basically, if I have a type of struct foo, and I have over here the you know, like struct a, right? And this doesn't work because the field has incomplete type, even if I declare it later, right? But if I do a star, then this works. I don't even need to define it if it's always behind a pointer, it seems, right? So the question is, if I have then the function pointer, how do you declare the function pointers in C? C function pointer type. Oh, we need to declare it first though, right? Oh, this declares the variable, which is a pointer, right? You need a type decal. Hello. Type func arg. I want to just define the type though, right? Not to define the function itself. Or do you mean like you say like void f star like this? No. Is it common practice to use pointer as a nullable declaration? Pointer as a nullable declaration. I don't know. Or do you do like type def void f star like this? No. What is this website? cdecal. Declare x as a function. I don't want to declare x as a function. I want to declare x as a field, which is a function. Pointer. This is return type star name. So it's the star is on the other place, right? Star. Okay. And over here, can I do the same over here for the field for it to be in line? Okay. All right. I see. Yeah. This is my daughter, not son. But yeah, hello, Scott B. Say hi to chat. Hi. Over there. No? She doesn't want to say hi to you though. She just woke up. Cartel before 6 years old. Yeah. Oh. What was I doing? I was compiling. Does it work now? It doesn't work. Let's see what it does not work now. So now the first error is over here, which means that all of the types are actually specified properly. It seems, right? Because because the list is actually defined first. Also, I see that I'm missing the new line after the struct declaration. So let's fix that too. That's when I'm like doing this, right? Struct. Yeah, I just do this slash n here, slash n here, and slash n here. New lines are blowed. Then my first, yes. Okay, but the error actually, it says this. We have type info, type info. We have type info, type info, which is not there. Oh, but that is not here because this is a constant which we don't like do yet, right? That makes sense. So we are generating some type information. If we look at the generated JavaScript, I can show you what it is. So this is the runtime type information which we generate, but I'm not transpiling it to C yet. Right? Like for example, int32 type info is this, which yeah, it's a little bit weird here in JavaScript, but I think also because these are expressions, they should be like initialized before main. Even although like they are technically pure expressions, I think there is nothing actually to calculate here. But like, can you even define like a constant which references another constant? Especially if I have the if I have, right, because we want this type informations to be recursive too. I think I have not tested that in JavaScript yet either. Your third last is 17 years old. That's that means you're as old as my dad probably. What did I try to do? Right, like so we have like the type information, the runtime type information, which should refer to other runtime type informations, right? Because the types are supposed to be recursive, which means that I will not be able to do that as a constant. Can I? You know, so like we want to have type def struct tree, which has like you know, struct tree. Let's just have a list. You know, we have list and we have a list next. You know, and we have like the value here potentially, right? So I can say constant a is constant list a is next is null, right? Like for example, that works. Does it? Must use struct to refer to the type because I need to do this, right? Okay, but then if I, and then I can do list B, which is saying that next is a reference to A. Can I do that in C? It says initializing struct with an expression of type const. Yeah, it's just like const like this, right? Okay, but can I say that they refer to each other? That's the question, right? Can I say B here? We cannot. And the only way to do this, even though technically is there a way to do this in C with the constants? Because if not, then we will have to do this at runtime anyway, right? You can assign to B after declaring it. Not if it's a constant, right? Or can you declare a constant and not assign it? Oh, wait, you can. Constants are a social construct. Hold on, you're right. Seems like it's working. There's no way. You can forward declare constants in C. I did not know that. Okay, then it will work. Actually, I might want to have like some more complicated constants later, though. Wait, is this supposed to be a star? If not, list. Dun, 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 dun. Print list. Hey. Sleep. Yeah, the things work. You can only sleep for the seconds. You cannot sleep for the milliseconds. Or is it called nanosleep? Nanosleep is like the different thing. There we go. Microsleep for microseconds. Milliseconds. Like this. Okay. Yeah. 1 second is 1,000 milliseconds. Yes, but it's a million microseconds. Bum, bum, bum. Let's try to like write some code which does not use this this stuff, because I want to end actually. So let's just write some code. Does my hello world still works? Just see mini hello, right? Mini hello says less is not found. Yes. Let's have this in the runtime actually. Let's see, why not? We have like add. I will want to have sub greater less equal not equal. Less or equal. Greater or equal. Just so that we have this for the future. Less is a template, so now we just need to say less int 32. A little bit more verbose, but it's okay. It's a mini cast. We don't care about this. Call to undeclared function malloc. Wait, where is it? Oh, I see. malloc needs what? stdlib. So in the runtime. Does allocate need something? Memcopy needs a string h. Okay, but this over here is a 4, which is supposed to be... Right, this is not an expression, right? We need a statement. So this is supposed to be a statement. Here. Hello, Alhack. Statement. Say statement is false, right? Can I do this? Copy paste this to this C for now. It's over here. Now, if first I think I just do this raw. So over here I just continue this loop. Continue is kind of wrong though. Maybe I don't need to do it first here. Let's just always check for it. It's just if it's a statement, then we do the raw this thing. I just want to set the statement to be true now. Statement is false, right? So over here, this is the raw parts, right? But we are going to say that if statement, then I'm instead going to return void, and I'm going to insert statement, which is the raw parts, like this. I'm working on my own programming language, yes. And this over here, I'm writing it in my programming language too at this point, although, and right now I'm making this mini cast. My programming language is called Kast, and I'm making mini cast, which is a simpler language, which, and I'm working on transpiling it to C and JavaScript at the same time, and I'm going to transpile this language to minicast and then to the target. And right now in the bootstrap, it's transpiling to JavaScript directly. Well, I mean, it's written on the screen over here, right? Too. Okay, so once this statement, and I need the the CAST to be the statement. Statement is also going to be the raw parts, which is also going to be a list of expressions, I guess. Raw parts. So there's going to be here, and same is going to be on the statement. So we have a raw part statement, then we're going to do this. Okay. This might work. Nope. Return void. Yeah, because this needs argument, which is the spend. So this is the code that I'm trying to compile now. This is the calculating the Fibonacci numbers, Fibonacci number 10. In this simple language, we don't have operators. I thought I would not have templates, but I added templates here today, which are working similar to C++. And there you go, it works, right? There you go. Fibonacci 10 is 89. And this works in both C and JavaScript backend. No, it says cannot find template less. Okay. That's because I need the runtime. Let me do this in the JavaScript runtime. I suppose I need some math here. It is looking the same in JavaScript, except for the equals. This will be triple equal and triple not equal, right? The roundup is probably not needed. I just use it for calculating alignment. Previous definition is here for add. Ah. Wait, previous definition is over here. Yeah, and for this runtime, we actually don't need it then. We just have the print string. Okay, there we go. Now it works through C and through JavaScript. Okay, let's do a smiley face commit, and I think that's going to be it for me for today. So thank you guys for watching. Next time more progress is going to happen. Could we manage live? What's Reinhard doing? I don't know this guy. Oops. Like they're working on a game probably. Game dev, pixel art, C++. Nice. Alright, sure. Okay. That's it for me. Thank you for watching. Bye.